All right, I'm here with Patrick. He is a college freshman out in Ireland studying computer science, as well as he is an upcoming intern. So we're going to be doing a sort of Google style, if you will, mock coding interview. So there's going to be two different questions I ask him. The first one is going to be in this video. And then after you finish this video, there's going to be a second question that I ask him over on his channel as well. Okay, Patrick, are you ready for your coding interview?
Yes, I am more than ready.
All right. So the first question is called best seat. So the idea here is I'm sure you've gone to a movie or a play or something like that before, and you want to have some space, right? You don't want to be sitting next to other people. And I think for most people, the aisle seat is sort of like the best seat or whatever. But in this scenario, we're assuming the aisles are both taken. So what we want to do is find the seat that has the most space. So meaning we are as far away from any other person as possible. And this is going to be represented as an array. So if you look at the sample input, you can see we have seats 1, 0, 1, 0, 0, 0, 1. So zeros are seats where nobody's currently sitting there. And a 1 is a seat that is currently occupied. So in the sample input, like we said, the aisle seats are occupied. And then there's one other seat occupied in sort of the middle. So the seat at index number 2 is occupied. And we have 4 seats that we can choose from. So we can sit at index 1, or we can sit at any of these 3 towards the end. And we want to choose which one is the best and return that index. So the one that's the best here is going to be the one in the middle of these 3 seats at the end, because that's the only seat we can choose where we have sort of space next to us on both sides. Yeah, so
Mhm.
essentially the goal is find whatever seat's going to give you the most space. And when you have that space, you want to sit in the very middle of it. And if there's multiple correct seats, we just want to walk as little distance as possible. So just choose the first one that comes up that has that best possible scenario. Does that sort of make sense?
Yeah, that makes sense. So we're having an array, and a one represents a taken seat, and a zero represents an empty seat, right?
Yeah.
Okay, so what if can it ever be all ones? That wouldn't be
So I think you can assume that there will always be at least one empty seat.
okay. So whenever you see a potential zero, that could be it. Okay. So essentially, we're looking for the zero that has the most surrounding zeros.
The zero with the most surrounding zeros. Yes.
Okay. Okay. Perfect. Okay. Let me just think on this for a second, then I'll ask you a few more questions. Okay.
Sounds good. Actually, zoom this in a little bit too, so see it a little better.
Okay. Let's see with the okay. We start at one. Okay. We go to zero. Okay. So what's jumping to me? Okay. When we're searching, if we see a one, we're just gonna ignore that because it's already taken seat. Okay. Then we start with a zero. We will check adjacent. We will check adjacent seats to see whichever one's zero. If we have a zero, I guess we'll have some kind of like 2 pointers or something that the right pointer will go to the right, and then okay, we see the 2 zeros, so then that length is 2. I'm going to keep track of a length as well as the index. So if I see another one that has a greater length of zeros, then I'll change that accordingly. So that's what jumped to me straight away. But okay, so in this case, when we have a zero, okay, so we have 1 0 1. I'll check the left and the right. No, we have ones. Okay, but we found a zero, so we're gonna check if is that the longest zero we have so far. And if it is, then I'm gonna store that in a like a in just in a variable at the top. If you understand what I'm saying.
Yeah, I think that makes sense.
Okay, and okay, so once we've searched the left and the right. Once we have searched the left and the right, I we do not need to search them cells again. That's what I'm thinking. So in this case where we have a zero, right? I'm looking left, looking right. We have two ones. Okay,
Mhm.
I check. Okay, the length is one, index is one. Store that in our result. Cool. Then we go past one after the right variable because the right is going to be currently at 1 and 1. The right is going to be at 1, like the one beside the zero. Sorry. So index 2. You
Yep.
understand what I'm saying? So then we're going to see a 1. Okay, we just ignore it and we move our left to the right plus 1, and then we start again from there. Cool. We're going to now check left and right. Left is a 1. We're going to ignore that. Cool. We're going to see right is a 0. Cool. We go up. Right is a 0 again. We go up. And then we go up again, we see a 1, we don't count it. And then see, we get r minus L, which is going to be 3 here. So I think it'll be 3. So then, I'm thinking here. Okay, we're going to assume that 0. No, that algorithm wouldn't work because it's not, yeah, I'm thinking of length rather than actual adjacent space. Okay.
Well, can you use the length to find that adjacent space?
I definitely can. So let's say, okay, we're at that 0. We keep going, going, going. Okay. Oh. So okay, right now my left's going to be at that 0 right after the 1. So index 1, 2, 3. And then we keep going until we find a 1. Once we find a 1, we're going to check the middle. And whichever one's in the middle is what we're going to add to our result and the result length. And then at the end of the algorithm, we will return the result, which is the index, right? Yeah, you want me to return the index. So yeah, I return the index. Does that make sense to you there?
Yeah, I think that makes sense.
Okay. Okay. Just wanna see how exactly I'm gonna code this out. Okay. So we're gonna start at index. Is there any constraints here? What's the minimum length that seats could be?
I don't think there's any. Well, the minimum length you can assume, like we said, the aisles are always taken and there's always an empty seat. Actually, it does say on here if there's no seat to sit in, return -1. So let's say maybe that constraint's not true. Maybe all the seats could be taken, and if they are, return -1. But we can assume that there's always seats, I believe. So let's say that there's always at least uh, one seat, I suppose.
Okay.
But it doesn't matter too much. I wouldn't worry too much about that fine detail. It's a good thing to think about, but yeah, if it's easier
Okay.
to make one assumption or the other, I'm not too worried about that.
Okay. So, okay, I'm going to set my result starting at -1 as the index and 0 as the length. So then in the case where we don't find a 0 at all, then we just return -1. But you guys already, oh, well, it already says return -1. I'm going to take that off, of course. Okay. So, yeah. Okay. So I'm just seeing how I'm going to structure my two-pointer approach here. Okay, we have left and right starting at the second. We're starting at the second position. So at index 1. And we check basically we're going to check the cell to the left of the left and to the right of the right. So when we check to the left of the left here, we're going to see a 1, we're going to ignore. Then which we see the right of the right, we see a 1, we're going to ignore as well. Then where we saw that 1, we are going to move our left pointer up to there. Then we're just going to keep having that check. So whenever we see a 1, move our left and right up, and then whenever we see 0, we'll then check the left and right. Okay, there it's going to go right up, right up. Okay, so I think I know how I'm going to do this now. So am I comfortable to start coding now?
Yep.
Okay, perfect. So, okay, so I'm going to start left and right equal to 0. And left and right equal to 1, actually, because we're going to start at the index of 1. Okay, okay, so we're going to start there. Now, while r is less than the length of seats, so once we've checked every single seat, basically, well, r is less than length of seats, we're going to check, okay, left is equal to L at L minus 1. Hold on a second. L minus 1. L at L minus 1, now we'll get the previous cell, and right is equal to the R at R plus 1. Okay, I'm trying to think here. Okay, if I go to zeros, do I? I'm thinking, I don't think I even need to have a left pointer checking the left. I think I could just have the right pointer checking the right, and then we grow from the left to the right, and then yeah, I don't think I'm gonna even need to get the left to the left, but I might backtrack on that decision later on. But I'll see if right is, I'm going to see if it is less than, we're going to be checking the right. So I'm going to say R is less than then seats minus 1 because we're going to be checking the last index in the last iteration. We don't want to go out of bounds and have any errors there. So,
Okay.
so while right, okay, if right is equal to a integer 1, if right is equal to integer 1, then we're going to set left. So we're going to set left equal to r plus 1. I think I'm going to put like a while here.
Okay.
Left is equal to r plus 1. So while, no, because right, okay, left is equal to r plus 1, r plus equal 1. Yeah. So while we have a 1, we're just going to keep moving left up, r plus equal 1, or at the end, I guess I could just put this L is equal to r plus 1 at the end. Just there. After the
Yep.
while right is equal to 1. So then we're going to keep skipping the ones, and then once we've skipped all ones, our left is going to be equal to the right plus 1. But I think I'm going to set it to r. Yeah. Yeah, just for the, yeah, left's equal to r. Because then it's going to stop when we set it 0 or we hit out of bounds. So, and r less than 6. Yeah, just to make sure. So we're going to keep going up as much as we see ones. If we go out of bounds, we set left equal to r. Once we're out of bounds, the while loop is going to break, and then we can return whatever our res of 0. I'm going to use a tuple here for
Okay.
res. So it's going to hold the index and the length. I'm going to start it at 0 and -1. So res of 0 is going to be the index that we're going to return. So, well, okay, so now this is our case where we have right is equal to 1. Now, let me think. Okay, what if right is equal to 0? Well, right is equal to 0 and r less than lambdas, we are going to, nice syntax here. Okay, len seats. While r is less than len seats, I'm spelling this wrong. So while we have a 0, we are going to r plus equal 1, and we're going to check against our res. So if r minus l is, if our current length, this is r minus l plus 1. Yeah, if our current length is greater than the result length, then we're going to set res equal to the tuple containing r and the middle. So we're going to need to get the middle. So yeah, in the case where we have there, we want to get the middle index. So r minus l. So l plus, I'm going to use l plus r minus l. L plus, oh, sorry. L plus r minus l divided by 2. This is just in case that the length of seats is like a near the max integer. I don't want to do L plus R because then that would just break the code. There's what
Okay.
I'm saying there. So I'm just going to do res equal to that and comma the length. So this is in the wrong place. Sorry. R and this is on the right side. Yes. So while right is equal to 0. So say here, okay, we start on the first index 1. Right is equal to 0. And right is less than len seats. We are going to check, is the length r minus l plus 1, is that greater than res at 0? And r minus l plus 1 in this case is 1 minus 1 plus 1, which is length 1, and that is greater than -1. So we're going to update our res to hold the current index of that 0. And hold on a second, the index, I did it the wrong way again. So it is supposed to be this way. Okay, so that's index, and that's the index, and the length is just r minus l plus 1. Yeah. So this is the mid index that I'm getting on the left side, and the length is r minus l plus 1 on the right side. Okay.
Okay.
And so we have a 0. Our right point is going to increment, and then we're going to hit a 1. So this is going to stop. The while loop is going to stop. And while right is equal to 1 and r is less than len seats, we are going to increment R. So R is going to see that 1. It's going to increment to where we see that 0. And it's going to set left equal to that specific position. So then we're going to make them checks the next iteration. So now we're starting at that 0. We are checking, okay, so we see another 0 in this iteration. We are going to increment, check the length. The length is 2. We're going to get the mid index, which would still be the index of 0, 1, 2, 3. Then it's going to increment again to index 0, 1, 2, 3, and 4, 5. So our left's going to be at index 3 and our right's going to be at index 5. And then it's going to get the mid index, which will be index 4. It's going to store that in res, as well as the length, which is 3, I believe. Yes, the length is 3. And it's going to increment our right pointer. And then we're going to hit that 1. And once we hit the 1, it's going to stop this while loop, go to the second while loop. And then it is going to go out of bounds, and then our loop will finish, and we're going to return res at 0. I think that's
Cool. So a couple questions for you.
right.
First, we have right, and we also
I
have
don't, yeah.
are. So are those intended to be the same, or are they different?
No,
Like, what does R represent versus what does right represent?
I was just about to remove that actually. Well, or okay, so yeah, okay. We're gonna just do theta R. Little silly mistake there. What theta R is, we don't need that. Theta R. Yeah. I think I'm gonna put this R is less than len seats before, because yeah, that would have broke if we actually went out of bounds. Sorry. And
All right.
seats.
Oh, I see. Yeah.
And yeah, I'm just gonna put this to the left. Well, R is less than len seats, and theta R is equal to 0. These are integers, yeah? Your integer 0 and integer 1, right?
Yeah, they're
That it
integers.
can be, okay, they're integers, okay. I think that's everything. Can I just run through? I'm just going to run through one more test case just to make
Yep.
sure.
You can also,
Ooh.
if you want, you can either manually run through a test case, or there's also like the quick test thing on AlgoExpert where you can like type in a test case down there.
Oh, I can? Where? Oh, quick
The
test.
bottom
Oh, okay.
left, yeah, quick test, and you can put in anything you want, and you can run the code, and then it'll run it with that.
Okay. Okay, I'm trying to see here. Okay, we'll start one at 1 and 1. Um, R is less than seats, and theta R is equal to 0. We are going to check the length. The length is 1. So now our result is going to hold index 1 and length 1. If R minus L plus 1, the length is on the right side. So it's going to be, yeah, if R minus L plus 1 is greater than res at 1, that's the length. Okay. Yeah, I would have ran into that bug if I didn't test it out. Okay. So we're going to increment R. It's going to be now index 2. The length is greater. Okay. We go to the next. We increment R again. The length is greater. So then we're going to get the mid index, and that's what's going to be stored. So index 0, 1, 2. Index 2 is going to be stored in res, and R is going to increment again, and then it's going to hit a 1, and then we're going to go out of bounds, and we're going to return res at 0. I think that's perfect.
Cool. Do you want to, if you click run code at the top right, it'll run the code against the quick test. You can see if it actually works.
Mm-hmm. Mm-hmm. Run code at the top right. There was an issue.
All right, so if we go to raw output, you should be able to see
Indentation error. Huh?
indentation error. See res. I think is the first line. Is there an extra space there? Maybe.
No, I'm not seeing any.
Maybe
I'm not seeing any right here. This was unexpected. Res equal to.
let me see.
Because I was just using tab, but the tabs looking like different.
Something. Or sometimes the indentation error comes if there is a different, like, if there's something that is illegal syntax, it can cause it to think it's an indentation error. See,
Oh yeah.
I don't see anything that looks. Let me. I think these are indented 2 times, so everything needs to be here. I can actually I think if we do
There.
that, yeah, try and run it again. There we go.
Oh, the
Cool.
code
It looks like
passed.
it yeah, it looks like it passed on this one. Um, are there any
Hmm.
other cases you wanna think about, or we could also just run it against all of the test cases on AlgoExpert as well?
Okay. You said that we could have all ones. Let's see in the case that we have all ones. Oh, sorry. This case that we have all ones, so this should return -1. Yeah,
Yep.
-1 was returned. Let's see here. If we had 0, it should return 2. It does return 2. Let's see. Okay. I want to make this a bit larger. 1, then we have a 0, 0, 0. This should return 0, 1, 2, 3, 4, 5. This should return 5. Yeah, perfect.
Yep.
Yeah. Yeah, that's perfect. I think so.
Cool. We can also, if we go to the test tab, we can run the code and solve the test. Yeah, it looks like it passes. It
Okay.
seems correct to me.
Okay.
So, what about the time and space complexity? What are we thinking for this?
Yeah, I was getting ready to jump into that. The time complexity of this will be in the worst case O of n because we are only processing each cell, well, cell index once at most. So if the length of seats is 7, then the amount of iterations in the amount of cells we're going to process is going to be 7 as well. So that's going to be linear in terms of time. And in terms of space, this is constant space because we're only keeping track of indexes. No matter how large the seats is, we're only going to be keeping track of 2 things, well, so 3 things: L, R, and res, which is always going to be the same. So it's going to be constant space across all sizes of inputs.
Yep, absolutely. Yeah, this is one a lot of people get tripped up on the time complexity specifically because I think we see nested loops, and at least for me in my
Mm-hmm.
like intro coding class, it was sort of like told to us like it was sort of like a heuristic next nested loops equals quadratic time complexities. But
Yeah,
that's not always the case. And yeah, you're exactly right. So we only actually process every index one time. So yeah, we're going
exactly.
to get O of n. So one other sort of follow-up question on this, and then we'll move on to the next question. So I don't need you to actually code this. I'm just sort of curious to hear how you would think about going about this. So what if we had one more constraint to this problem that makes it a little bit more difficult? And that is we don't want to have somebody sitting in front of us, right? Like if I go to the movies, the optimal seat might be that there's nobody sitting next to me, but it's also that there's nobody sitting in front of me. So imagine we had our seats was a 2D array instead of just an array. And what we wanted to find was a seat where we have the most horizontal space, but also nobody sitting at the seat directly in front of us. And like I said, you don't need to code it. I just like to ask that as sort of a follow up to see like how you would think about adjusting this to solve that problem.
Mm-hmm. Okay. Okay. Um, you said 2D array, and we're gonna, instead of checking left and right, we're gonna be checking left, right, up, and down, basically. You don't want,
Not
okay,
necessarily. Well, potentially from any individual seat, we don't really care about behind us, right? So we don't care about up necessarily. We just kind of care about down.
down,
But
left,
yeah,
and right. Yeah. I guess that would be just a like a graph BFS. To be honest, I think that would be a graph BFS, and then we like keep track of the amount of oof. But how do you get the middle seat is the real thing here. Hmm. Guess I'll have to visualize it out. Okay, 0. Let's say we have 1, 0, 0, 0, 0. So we're starting at a specific seat. Okay. We check down, we check right, and we're still trying to return the index, right?
yeah, we're still trying to. So in this case, we would return essentially the row index. So what row are we sitting at? And we don't care what row it is. Like we're not like, oh, I want to sit in the front or the back or whatever. But we want to just return whatever seat has no or has as much space to the left and right of us. So the same thing as before amongst all of the different rows. So essentially, we're doing the same question, but on every row in the theater. And then the one extra constraint of we don't want our result to have somebody sitting directly in front of us.
Hmm. Okay. Well, like to me, it kind of seems like I need to just traverse down, left, and right, and kind of like spread. Kind of like I'm checking each one, and I'm accessing so say we started at a 0, right? I'm checking all surrounding zeros that there is, and then I put the hard thing I'm thinking there is how am I going to get the middle? That's the only thing that
Right.
I'm thinking there. Ooh, that's actually a very interesting follow up. Um,
Yeah. Yeah, it
the
makes the
middle.
question like it sounds when you first say it like, oh, it's not that much different, but it actually makes this question like
It
significantly
actually.
more difficult. That's why I would never ask somebody to actually code it. But
Okay, this is what they be asking you in meta, is it? This is okay.
so
Hmm.
one thing to think about is let's forget about the constraint of we don't want anybody sitting in front of us. There's sort of a middle version of the problem, and that is the same problem we already had, but you just want to find the best seat by the previous uh, like version, just with multiple rows. So if seats here was a 2D array, we don't care about if somebody's in front or behind us. Um, how would we solve
Oh,
that sort of
I'm
middle version of the
thinking.
problem, which is just like we want to figure out which row has the seat with the most space in it. Say the first row you have index 2 was the best and it had 5 spots. Right? That doesn't make sense. Index 3 had 5 spots, and row 2, index 4 was the best and it had 2 spots.
Next four had 2 spots. Okay. Okay. Let me use a scratch pad right here
Yeah. Oh, yeah. That might be a better thing to do.
because it's a lot of words right there. Index. So let's say index two has. Okay, let's see. Seat number. You said seat two has of length what?
Here, let me.
Yeah,
Here, I can write this in here. That'll
you
probably be
could type
easier.
it out. Yeah.
I'll erase this for a second. So let's say our answers were um, row 1. We could sit in index 3, and that had a length of 5, or row 2, index 2, and that had a length. And I changed these numbers. These aren't the same as what I said before because I forgot what I said before. But let's say we had that. Which seat would we want in this scenario?
Okay, index three definitely has the most space.
Right. So index 3 in row 1 specifically, right?
Yes, index three in row one has the most space.
Yep.
Index two in row two has length of 2.
Yeah.
So we would want we would want to go for doing with the larger length.
Yeah, exactly. We just want to go with whichever one has the highest length, right? It's the same thing as
Highest
the
length.
original problem. It's just
Yeah.
we want whichever one has the highest length. So if we had, say, 10 rows or 100 rows or whatever, um, how would we decide amongst all of the rows which one to sit in?
Hmm. Say check which like would kind of check between the current row's max length as well as the row in front of its max length, and whichever row has the highest current and front, then go with that.
Highest current and what do you mean by current in front?
Current like so whichever row has the highest. Say you said here index three length 5, so that's the best seat on row 1, and the best seat on row 2 has index 2 is length 2. So whichever row whichever row kind of like has the highest current, so the seat that we're in has the most space there, and as well as the seat in front has the most space. Is that what we're
So,
wait?
oh, I see. So are you still thinking about the version where we care about the person in front?
Yes.
Okay, I was just asking like in the sorry, I might have not articulated that well. I was asking like a simpler version of we don't care about who's in front of us at all.
Mm-hmm.
So
Oh.
if we don't care about who's sitting in front of us, all we care about is uh, which seat gives us the most space, not vertical
Oh.
space, just
Oh.
horizontal space.
Oh, sorry. Okay, so we're gonna just traverse each row. We're gonna do the function that I just made here. We're gonna run best seat on that array, and what's gonna be returned from that? Instead of returning res as 0, we're gonna return res at 1, which will just return the length. And I'm gonna store each of their values for each row. I'm gonna run it and store each of their lengths in an array, and then I just return the max in the array.
Yeah,
Or
exactly.
wait, but you want me to return the index as well? So I would in the function in the array, I would add the entirety of res, so then I can get the max based on the first index, of course, of the tuple, and then I'll just return the index from there.
Yep, exactly. So the part of who's sitting in front of you is sort of a uh, it makes the question like infinitely more difficult.
Yeah.
So if we think about that version of it for a moment, and I sort of like the way you're thinking about it, is we can find the solution we just found, right? Pretending that we don't care about who's sitting in front of us at all, right? And
Hmm.
then we do care if we do care about only the seat directly in front of us. So we don't care about like how much space is in front of us, just strictly is the seat in front of us occupied or not? If it's occupied, then our current solution is just not a possible solution. Um, so
Hmm.
then it becomes a question of okay, if we can't say we can't sit at whatever our solution was because somebody was sitting in front of us, what is the next best solution? Um,
The next best solution.
so it's
Okay.
essentially like take the solution we already have and find that next best solution, and um, that is actually a question that gets that's the one that I would say I would never ask somebody to code because it gets very complicated. But I think um, for the sake of time and to move on to the next question, I think you did a pretty good job of like articulating how exactly you would at least think about it. And there are actually
Yeah.
different solutions to it. It was interesting you mentioned thinking about it as sort of a graph. That's not a way I really thought about it, but that is in a
Hmm.
way you could think about it. I think the
Hmm.
simplest approach is to sort of do what we just did, but uh, then essentially do that almost like backup thing of like, okay, if I can't sit there, but there was a length of 5, well, that means I could potentially sit at the seat right next to it and have slightly less space. And you sort of end up having to look at a lot of different seats. Um,
Yeah, that's what I was thinking. I would have
so
to. Hmm? Yeah.
yeah, so yeah, so if you do it that way, it becomes this like exponentially slow thing. So essentially, you have to update the best seat function in such a way to where it will never pick a seat with somebody in front of it.
Hmm.
Because otherwise, if you try to like do that backtracking thing, it'll take forever. Um,
Okay. Okay. Can
yeah.
I just add one
So
thing?
yeah. Go ahead.
For another thing. So yeah, so I guess how I would modify is while I'm searching and see if we have a oh sorry. We have a potentially longer length. I'm gonna now check is the one directly under it free as well. If it's not free, then I'm just gonna completely ignore it. Is that what you're trying to do here? You're just trying to we're trying to
Yeah.
basically completely ignore it. Yeah, so then we're just gonna keep going like that. But if yeah, that's I think that's the only fix I need to make.
Yeah, it's
Just check I can do it.
essentially pretty similar to that. Yeah, if you find it, if the seat that was the best is like not a seat we can sit in because of somebody in front of us, then yeah, we essentially have to look at instead of that middle seat, we have to look at sort of slowly go outward from the middle and look at the seat next to the middle seat and say, could we sit here? And if we could sit there, great. See, is that better than our current best solution? If it's not, then we're never going to find something better than our current solution by moving away from the middle even further. But if you can, you kind of just keep moving away from that middle. Yeah. So great job on this. And I only even asked the harder follow up question just because you solved this pretty quickly. But
Mhm.
let's go ahead and move on to the next question. So for people watching, this is the next question is going to be over on Patrick's channel. So there'll be a link somewhere on the screen to go jump over to that video.